Alright, so let's say I start with this line here, print is odd 4. So we know that execution goes from right to the left side of a statement. So this is the first thing that Python is going to try to evaluate, is odd 4. So 4 is the input, is odd is the function. So Python is going to look for a function called is odd, is going to call that function, and is going to pass to it an input of 4. So that's what's happening here. So we have the isodd function running, and x in this case here is 4. It passed an input of 4. So it started running of a new function. Now this function has a statement. It has one statement. It says return not is even. So again, execution moves from right to left. So the first thing it's going to try to execute is this is even function, and it's going to pass 4 to it. So it looks for is even, and it finds is even, and execution goes like that. So x here is 4. The is even function has 4 lines now. So x is 4, so the first thing it checks is 4 is equal to 0. That's not true, so this line doesn't happen. It goes to the else statement, and it asks, okay, return is odd. So again, from right to left, the first thing it's going to try to do is execute is odd. It decrements x, so x is 4, 4 minus 1 is 3. So it's going to call is odd, but it's going to pass 3 to it. So what's really important to note before we go any further, this, I have this in blue here, this is odd function is not the same thing as this is odd function. It's two totally different functions, because what's happening here in recursion, is the whole idea of recursion, is that it creates new instances of functions. So what really happens here is that when we call, so if we go back to this point here, when we call this is even function, this particular is odd function, what happens is that it gets put on pause. So we pause the running of this is odd function, and we spin up an is even function, and we go down here, and this is even starts to run, and when this second is odd is called, this is even function here is put on pause, and it's going to try to execute the is odd, and when it's finished it's going to continue running the is even. So we continue down the line here, is odd 3, and is going to spin up a new instance of is odd, this time with 3. Is odd, one line, return not is even, so it's going to spin up a new is even, pass 3 to it, execution goes down like this, a new is even, x is 3. Is 3 equal to 0? The answer is no, so this doesn't run. Else return is odd x minus 1, so x is 3, x minus 1 is 2, so it spins up a new is odd. So we go like this now, new is odd, this is 2. This line, well, again, return not is even, so it starts a new is even, passes 2 to it, execution, new is even, x is 2, 2 is equal to 0, not true, doesn't return true. Else return is odd, x is 2, 2 minus 1 is 1, so it starts a new is odd function with x as 1. Return not is even, so it starts a new is even, x is 1, x is 1, is 1 equals 0? The answer is no, so this doesn't run. Else return is odd, starts a new is odd, x is 1, 1 minus 1 is 0, so is odd, new is odd, x is 0, return not is even, x is 0, start a new is even, x here is 0, and finally we reach this here. So this statement here is really important. This is what it's called, I'm sure you heard this already, this is the base case. So this is the smallest possible case that you'll ever have to check for. In this case, we're assuming that x is some integer, some positive integer, well, I assume 0 as well, plus 0. So this will not work with negative integers, because we're minusing, and if you minus from a negative integer, you'll get more negative. So it only works with positive integers. And your base case is 0, because 0 is the smallest positive integer. So it's also the smallest, or the largest negative integer. So this here is your base case. And finally, x is 0, so 0 is equal to 0. So this line here evaluates a true. So we enter this if statement and we return true. So this doesn't run in this function running in this function instance, and we return true. So I'm going to draw in blue now. So what happens is a value of true is returned upwards. I was going to represent true by the letter T. So this is even function here, it becomes true. So when we return not true is false. So this becomes false. So we're actually going to return, so this function here, this is odd function, is actually going to return false. So false gets returned back in that direction. So this is odd function is false, and we return false. So I mentioned the concept of pausing before, right? So what happens here is at some point, say this function here, this function was paused at some point. It was paused when we evaluated this is odd function. And what's happening now is that after we have evaluated that and we finally get a value return from it, this function here is now, this function is now going to change from being paused. It's going to play, it's going to resume execution. And yeah, so what's going to happen is we're just going to keep returning all the way up in this direction until we return some single value. So I'm just going to continue because it won't take too long. So return false, so returning false, so this is even, returns false, is even here becomes false, not false is true, so this is odd function returns true, so true, is odd here is true, so we return true. This is even, it's going to return true, is even here is true, not true is false, so we're going to return false. So this is odd is returning false, and right, so this is false now, so return false. This is even is returning false, and is even here is false, so not false is true, so return true, and the final thing that's returned here is true. So, oh sorry, I have one more to go. Geez, I mark up a lot here. So return true, this is true, this is even is true, so we return true here. This is even is true, not true is false, and finally we return false here. The initial question is odd 4? And the answer to is odd 4 is false, because 4 is even. Now I don't know if you knew that all of this occurs. This entire madness here occurs in the background in order to answer this question. And that is why recursion is bad. It's a nice way to solve certain things. Sometimes it's the only way to solve certain things. But the trade-off of that is you end up with a bunch of executions happening in the background, and that costs time, it costs resources, which is why if you could come up with some non-recursive method to do something, that's always best.